Hello and welcome, guys. This video is just a quick demonstration of the speed and simplicity of the EasyCFD workflow. If you wish to learn more, then check out the tutorial videos on this channel. So the first thing we're going to do is just prepare our geometry, our simulation geometry. Just going to open up NGrid and import our STL. I'm going to be using this damper guy right here. Like I said, if you wish to learn more about the details of what's actually going on here, check out the EasyCFD 101 tutorial. But I can at least describe a little bit of what I'm doing. So in this program called NGrid, I'm defining my boundary conditions for the geometry, the simulation geometry. So I'm going to be having air pass through the sky right here. And so what I did earlier was that I specified my inlet. That's where flow is going to go in. Right now I'm doing my outlet where flow is going to exit. And then everything else is just going to be a wall. Now OpenFOAM can't do this on its own, so this is why I'm using this program called NGrid right here. So now I'm just going to export this guy as SU2 and save that. Alright. Now it's time to activate EasyFOAM, and this is a Python tool that I crafted up to swiftly build OpenFOAM cases. So we're just going to specify a place for our simulation to go. We can call this damper test. Select that guy. Oh, come on. There we go. Okay. Then we're going to, just going to make sure I'm in the right place. Then we're going to just use that geometry we just prepared. And I'm going to use a flow rate of 5 meters per second. It's going to be air. I'm going to be using 8 processor cores so it can run faster. It's internal. We're going to use 0 degrees angle of attack. It's going to be laminar. And build OpenFOAM case, and there we go, process complete. Alright, now we go to this guy right here, test clean. Going to right click this guy and open in blue CFD core, and we're going to enter this command, just prep, exactly like that, just prep. Okay. Right, here's a little reminder for what to do next. So we're going to close this guy, and then in test ran, enter this command, parafoam, and this opens the visualizer, the OpenFOAM visualizer, so you can see what's going on, see what results there are. So right here we see our, I guess, flow domain. It's called a block mesh in OpenFOAM slang, I guess. So then we're going to open up our STL geometry files. That's in the tri-surface folder, in the constant folder. I'm going to do that. Now it's all inside this guy right there, here, this block, and this block is this testran.foam guy right here. So we're just going to make it a little see-through. There we go, so now we can see it. But now we're going to make the wall see-through so we can see what's inside. There we go. So now what we want to do is just specify a location that's not touching any of these walls and is inside it, so that OpenFOAM knows that flow is going through it and not like around it. So what we're going to do is just go to sources, sphere, click apply. Alright, that's way too big, so let's try adding a 0 there. There we go. Now we're just going to just move it around. Alright, there we go. So this is a good spot. 0.200. It's inside this block right here, and it's not touching anything. So what we're going to do is, let me see, where's my, okay. We're going to go into System, Surface Feature Extract Dict, open with Notepad 2. Whoops, wrong one. Snappy Hex Mesh Dict. Open with Notepad 2. and then we're going to just copy those coordinates right here. 0 and 0. Perfect. All right. Now we can close this guy up. And now we can just do snap solve. Hit that guy. And right now the geometry is what's called meshing right now. And then it's also going to carry out the flow simulation. So I'm just going to stop recording and pop right back in when it's all done. Alright. Alrighty, the simulation is complete. Now we can go into ParaView and see our results. Just type Parafoam into that terminal right here. Click apply. Come on. Alright, now we can see our results. Alright, let's see. What's good? Okay, here we go. So now we can see the pressure profile of our case. If we just use this, what is it, the slice filter right here, we can just get other perspectives here. There's that. That's P, that's pressure. Here's velocity. That's really cool. Let's see. So there was U, there was P. Let's get rid of that slice. Can we like go inside? Yeah, so you can see the flow hitting the wall, and you can see on the other side it's like a lower pressure area. So yeah, that's pretty much it. This was just one case that you can do out of like infinitely many, but hopefully within this sub 10-minute video you can see that with this EasyCFD workflow, pretty much anyone can do computational fluid dynamics simulations. Alright, thanks for watching, and I hope that you guys check out the rest of the videos on this channel. Alright, peace.